reality, hydrogen is a molecule that, well used, has enormous amount of advantages. Put a hydrogen production facility near the nuclear plant and do the integration to produce hydrogen. In the future, you will see a lot of hydrogen being used in industry. That's incredible amount of money that is put right now into hydrogen. We hope that in 10 years, all this high temperature steam electrolysis technology is going to be much, much more advanced. And I see that clearly. And nuclear has to be considered for in the energy mix. I think that's, it only makes sense to think about producing hydrogen, leveraging all that is coming from the nuclear plant.
Today, we're joined by Adrian Vega from Canadian Nuclear Laboratories, a man whose work with hydrogen is so cutting edge, he's practically making the rest of us look like we're still rubbing sticks together to make fire. Adrian, who's been busy bending hydrogen to his will, has done some groundbreaking work in high-temperature steam electrolysis, helped design new materials, and led a thermochemical cycle project that's more high-tech than it sounds. Plus, he's been scaling up hydrogen isotope separation. In short, he's the guy you want when hydrogen's around. Adrian, welcome.
Thank you so very much. Thank you for the introduction.
So, how does CNL's hydrogen research contribute to achieving Canada's clean energy goals?
I think CNL, or the working hydrogen that CNL is doing, is fairly, cutting edge in many aspects. We are not only dealing with or trying to improve the technology to produce hydrogen, but we're also looking at, how hydrogen interacts with materials, where to store hydrogen, how to leverage hydrogen as a fuel, for example, and use it in different applications, transportation or in industrial applications. We're also looking very closely at hydrogen safety. In this economy where hydrogen is taking more and more importance, is key to understand how to deal with hydrogen, how to use hydrogen. And so we had a large group of people understanding what are the risks, how to mitigate those risks. So really all the contribution that CNL is putting in hydrogen really is aiming to move that hydrogen to mainstream and making sure that we are aligned with the goals of reducing greenhouse gas emission, but at the same time doing safely and looking at different aspects, materials, for example, included in that mix.
So, based on your answer, you're a very good position to actually answer the next question from your expertise. What are the biggest bottlenecks preventing hydrogen's widespread adoption?
I think one is for people to feel more comfortable of hydrogen. Sometimes you have this idea of how just you look at the risk of hydrogen, but in reality hydrogen is a molecule that, well used, has enormous amount of advantages. So I think a good stakeholder management is key. Obviously, developing the right technology and using the right time at the right with the right scope is key. But more importantly, I think is get the technology to the right level where we can really start using hydrogen. We have been recently moving towards, instead of only looking at only hydrogen, you start looking at clean fuel, because that'll give you extra, an extra bandwidth of operation in a way. And that is something that people start receiving also. People and industry start receiving, uh, very, very well, because you start linking hydrogen as a clean fuel, but also what is hydrogen doing to produce other clean fuels that allow us to just move to a cleaner economy.
In the same context, how can nuclear power assist in clean hydrogen production?
Well, nuclear. With a nuclear reactor, you clearly produce electricity, as we all know. But another thing that you have from a nuclear reactor is heat, steam, for example. So you take all that clean electricity and you take that heat that you can leverage from a nuclear reactor. You can use those two inputs into a process to produce hydrogen, and then you make the economics look pretty good. I mean, if you use, for example, you mentioned in the introduction, high temperature steam electrolysis. So one of the advantages of that technology is that you use less electricity because of the temperature effects. So if you have heat that is coming out from a nuclear reactor, where you can do a nice integration between the nuclear reactor and the hydrogen production facility, really your economics start looking pretty attractive because you have two of the main components that you need to produce hydrogen right there, coming from a nuclear facility.
Are there any studies in this context in terms of how much hydrogen actually we could produce with the current state of nuclear?
There are a few. I mean, there are a couple of planned sort of demonstrations in the U.S. where uh, put a nuclear, put a hydrogen production facility near the nuclear plant and do the integration to produce hydrogen. There are different capacities. Some of them use the high temperature steam electrolyzers. Some of them use, even other electrolyzers like PEM. And so more and more you start seeing um, that interest in trying to link the two technologies. Of course, you have to consider different aspects, such as is the nuclear facility is going to be still or going to be installed right next to the nuclear facility, or is going to be slightly, separated, and that just create a different conversation, right? How much integration can we do, and how do we want it inside the fence or outside the fence, and things like that. But in the U.S., as I said, there are a few projects in the motion, trying to make that demonstration and use the advantages of nuclear facilities for producing hydrogen.
So, based on the current experience and also these demonstrations, which hydrogen production method holds the most promise for large scale use?
Well, I think for a clean hydrogen production, electrolysis is one that is very attractive right now. We have, there are different electrolyzers that you can use. You have the PEM electrolyzer, the polymer-based electrolyzer, or the alkaline electrolyzers. Those are technologies that have been around for quite some time, many 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 hours of operation. But the high temperature steam electrolysis is a technology that is coming along, and as I said, the advantage being the less use of electricity, the more use of thermal energy, and so I think this is a technology that for large scale is gonna be really making an impact. In many conferences you hear how more frequently people start talking about electrolyzers to produce hydrogen in different capacities and in different scales. But we are getting to the point that all the technologies have been considered, and the reality is also comes along what is the maturity of those technologies right now. And you know as much as we would like to push and we are pushing the high temperature electrolysis, the reality is this is a technology that, compared with the other two, is still need a little bit more advanced in terms of the TRL, or the technology readiness level, but it's coming along. It's just matter of just fine tuning the technology a bit more.
So, on your work with catalysts, how do you actually improve them? How do you enhance them?
Well, the beauty of the high temperature electrolysis is that you don't need novel metals. As you know, that's a difference with respect to for example, PEM electrolyzers. But in the high temperature steam electrolysis, you don't use novel metals. You use basically our ceramic materials, and so because of the effect of high temperature and so on. So really, part of the improvement of those materials have been not only the way the materials are produced, the characteristics of those materials, but also which materials do you mix? Because in the high temperature electrolysis, you don't have only one material on one end and another material on the other end. There are different layers of materials that, when you combine them and put it in the right way, might determine how long that cell is going to be, how long that cell is going to be alive, or what, reliability you might have out of that cell. So really, it's a process of, not only in a way optimizing one material, but also optimizing the different materials that you need to put within the cell.
So, in that context, what progress has CNL made in reducing reliance on rare materials in fuel cells?
So we start this journey with high temperature electrolysis, focusing a little bit on the modeling side, but suddenly, or at some point, we realized, the key is to try to make that, um, make those materials and the cells in and the high temperature electrolysis to last longer. So we start doing some work on that a few years back. Then you mentioned it in the introduction. We decided to focus a little bit of time on the thermochemical cycle. So we put a pause in the electrolysis, but since, maybe in the last 3 years, we came back to that technology. And what we are doing is we have been mapping, all the a significant number of possibilities to of the materials that we can use on both sides of the cell. And so what we start doing is developing the capability not only to produce those materials in-house, but also having the necessary capabilities to characterize those materials and test them. So really, we go from production to testing, and all the layers in between, trying to find what are those characteristics or combination of characteristics in a material that allow us to have, better reliability at the end. And so that's what we are, a big part of our effort right now is exactly doing that. It's just developing materials and developing steps or processes to run those materials, because you can have a good material, but if you run that cell not the right, in the right, with the right steps or in the right way, you might not have a really good output. So it's a combination between materials, but also process, how you run the process.
So basically, you're there living on the edge and pushing these technologies further. So, from that perspective, that you see, how do you see, where do you see hydrogen making the most impact in the future? Transportation, industry, or, energy storage?
I think that in the future you will see a lot of hydrogen being used in industry. That's for sure, and clearly even in transportation. But I think industry is gonna take that hydrogen, and now right now we use a lot of hydrogen in industry. It's just that the hydrogen is being produced by methods such as steam methane reforming. In Canada, more than 90% of the hydrogen used is by steam methane reformer. So if we are able to produce that hydrogen, a clean hydrogen, industry will be more than happy to take it. It's just beneficial not only for them, it's beneficial for everybody. So I see industry as a main off taker. Uh, Clearly, transportation is also coming along. But I think one of those areas that is going to be a major intake, it will be industry.
So, yeah, you're just opening other questions. Uh, how do you address concerns about hydrogen's energy efficiency?
Well, the energy efficiency, you have to, depending on the technology you're using, you're looking at different things. You're looking at, how well you do the thermal management to produce hydrogen. How well can you store that hydrogen? How do you use the electricity? Either if you use surplus electricity, or what amount of electricity you use to produce hydrogen. All that had an impact on that efficiency. So working on those aspects and finding better ways, not only of doing, as I said, thermal management, or using finding the right scheme to use electricity to produce hydrogen. All that has to be properly determined to really make the technology even more attractive, but it's doable. It's just that is the normal sequence of developing a technology and making that technology part of of the big mix in terms or energy mix is key, and it's manageable. It's just it has to be addressed properly, and that's all it is.
So it's basically just a focus of science that has changed now to hydrogen and that will advance it.
I think so. I think that's integrating the hydrogen processes with other processes out there to make the economics work, to make the process more attractive is key. I think sometimes just thinking of a isolated hydrogen production plant somewhere, yeah, okay, it's has merits, of course, but how do you integrate that with existing processes to make better economics, to make better use of that hydrogen, to help other industries to decarbonize? It's I think it's a major step forward.
What specific hydrogen technologies are currently being researched at CNL?
So at the moment, we are mostly focused on the electrolysis part, specifically the high temperature steam electrolysis. That has been our major focus for the last 2-3 years. As I said, aiming not only to improve materials, but we are doing a lot of work in, modeling the technology, understanding the economics. That is, we have a large group of people doing that right now. We have a lot of collaborations moving forward. In terms of producing hydrogen. And as I said before, we are not only looking at or saying producing hydrogen, we are just looking at clean fuel production because that is a major shift in the in this technology. So, but in addition to that, we still do a little bit of work on the thermochemical cycle as a hydrogen production process. Um, the bulk of the work happened a few years back, but we're still pushing to or looking for options to really move that technology to the next level, which is scaling it up. That's not something that really CNL can do by itself. It's just we're looking for partners that are interested in, you know, looking more closely at that technology. And I think with that will come, a better assessment of the economics and how well that process can be, connected with other processes out there, with where especially when you have waste heat and so on. So I will say the majority of the effort is in the electrolysis part, but we're still doing a little bit of effort on the thermochemical cycle process.
So we're still staying with CNL. What are the recent breakthroughs in this part of your work with hydrogen?
Well, I think recent breakthroughs come also from the uh, sort of process integration that we have been doing recently. We have been very successful at connecting with groups out there that are interested in looking at hydrogen. We have successful projects of assessing the use of hydrogen in locomotive, for example, and a big project went through to assess the economics of implementing hydrogen. I think that was at the end the process didn't move or the project didn't move forward, but I think just all the analysis that was done was a very good source of data for other groups out there to see, okay, hydrogen can be used in this kind of applications. We are currently dealing with or working very closely with the Coast Guard because they want to assess the use of hydrogen in their vessels, and so those uh, engagements with different industries really start making more resonate more the use of hydrogen in different applications. Now, on the other things we are doing, for example, we are moving forward an initiative to establish a hydrogen safety center, and that is CNL is leading that effort. And the main goal here is to have a center where it's like a hub where people that are dealing with hydrogen or have um, issues with hydrogen, we can act as a hub to leverage solutions not only within CNL but also with other industry to try to solve those problems. And that has been very well received by industry because there was not such a concept out there just yet. And we're in the final stages of really completing that the establishment of that center. On the production side or a clean fuel side, I think we one of the breakthroughs that we will be hopefully accomplishing in the next few months is to develop some technology and demonstrate the technology in an industrial facility, because some of this technology have been demonstrated at the laboratory level, but we are bringing some of this technology, putting in the middle of an industrial facility, integrating partially integrate that facility with the rest of the components that are in that industry, and demonstrate that you can produce hydrogen or syngas. And that demonstration itself will help us to move the technology readiness level, and therefore start moving that technology forward.
It's very interesting to hear that there is so much movement in this research, and what I'm now really interested to hear from you as a scientist who's working on that. What do you consider a major breakthrough, like on a scalable level? What would you consider a very big result in terms of this work?
Well, I think if we can, let's say at the level of the work we are doing, if we are able to come up with a way of running the electrolyzer, by a way of running, I mean either because of the materials we use or the way we run the electrolyzers, um, if we can expand the lifetime of those electrolyzers to be reliable for many, a few thousands of hours, to make sure that you have a steady performance that under a specific condition or with the specific materials you have, high output and high efficiency and so on. I think that's definitely a breakthrough. Number two, the same technology that we are using to produce hydrogen using high temperature steam electrolysis can be used to produce syngas. And instead of the basic difference is, instead of just putting um, water or steam to the electrolyzer to produce hydrogen, you put water or steam and CO2. And so that CO2, you can take it from industry that are just, dumping that to the atmosphere. But if you take that CO2, you put it through, you co-electrolyze that and produce syngas, and understand, how that happens. Make sure that you have a good efficiency in the process. Make sure that you can run the cell or the cells for a long period of time without losing activity or efficiency in the process. I think that's a major breakthrough, because syngas is the building block of many molecules. Name it: diesel, synthetic aviation fuel, for example. So if you can produce syngas, and at the same time you can leverage the fact that you are reducing the amount of CO2 that some industries are, dumping to the atmosphere, that will really make a shift in how we can see this technology moving forward.
That really sounds interesting. And you mentioned previously collaborations with commercial companies, and that this is really advancing and helping in your work. What partnerships or collaborations does CNL engage in to advance its hydrogen research?
Sure. Yeah, we have quite a few. As I said before, we have a very close collaboration with the Canadian Coast Guard that has been going on for a couple of years. Very synergistic, very well established collaboration. On the hydrogen, and we are developing other collaborations, for example, in the area of materials testing and understanding how hydrogen behaves under different or different materials behave under hydrogen and different conditions. That is key and very important. On the production side and development side, we recently announced, there was an announcement recently about a collaboration that CNL have with industries across Canada. Is funded by the government, but also we are leveraging, the partners we are all leveraging funding into that collaboration. So we have a partnership with companies that not only produce also high temperature steam electrolysis systems, but also we have a partnership with a company that the expertise is in producing synthetic diesel. And so what CNL and these partners are doing. By the way, it's a public information. We are partnering with Expander Energy in Calgary, with Fuel Cell Energy also in Calgary, which is the um, the manufacturer of high temperature electrolyzers. And so this partnership, what it's doing is not only, and there are two projects going on. One is looking into a paper study to understand the feasibility of producing synthetic diesel using the technology that Expander currently has, but also you implementing the use of an electrolyzer to produce hydrogen and a gasifier to produce syngas that can be used to eventually produce diesel. That's a paper study aiming that we are going to move forward in the process. Once the feasibility is complete, moving to a FEED study, and eventually the goal is to just continue moving the process, aiming to produce or establish the mechanism to really put a plant to produce synthetic diesel using clean hydrogen. That's one. The second one is a more it's a demonstration, and it's exactly what I was mentioning of putting an electrolyzer in an industrial facility. And so for that, we are also partnering with the cement industry, specifically St. Mary's Cement in southern Ontario. St. Mary's is also part of the first study, by the way. But in this particular case, St. Mary's is the host facility where we are bringing an electrolyzer installed in their site and taking some of the flue gas that is coming out of their stack and put it through the electrolyzer, aiming to produce the syngas. And all that demonstration is leveraging is not only validating how long that stack can run and how to run it, but also making sure that we understand, how to control the process to give us the right ratio of syngas. Because of that, it will depend a lot of the processes that are coming downstream, and that is key for us moving forward.
Knowing all that you know, and where do you see hydrogen in 10 years?
Well, I think hydrogen in 10 years, given all considering all the goals that we have, um, not only in Canada but abroad, to reduce greenhouse emissions, and given all the push that we have seen in hydrogen in recent years. Sometimes what we have noticed in the past is, you have a high in hydrogen, but then it goes to a low and then goes back up. What we have seen in the last few years is that it's a constant high, and is very encouraging, of course. And so I think my opinion is that is going to continue. There is a lot of incredible amount of money that is put right now into hydrogen research and hydrogen projects. Um, a lot of push to produce not only use as ammonia or produce methanol around the world. I mean, there are big projects all over the place. And so what I see is in the next 10 years, there will be more and more not only uses of hydrogen, but also the technology will come to a point where other opportunities will open up. So I certainly hope that in 10 years, all this high temperature steam electrolysis technology is going to be much more advanced, and that I see that clearly. And if that's the case, there will be much more opportunities to leverage heat and electricity to produce hydrogen. And with that, there will be obviously um, a great opportunity to just keep decarbonizing different sectors in our economy, which is obviously what we all want.
You mentioned Canada. How does Canada compare in the global hydrogen race?
Well, I think we are moving clearly in Canada in hydrogen. I think we need to probably move a little bit more aggressively in terms of the market, having a better idea of off-takers, for example. I think all that is going to be evolving as we move forward. Um, I think there have been clear goals of the hydrogen strategy has been published, in which we want to increase hydrogen production and increase market and off takers and so on. So I think that's helpful. Um, there is still more to do. Clearly, I mean, you have seen what is happening in the U.S. with the seven hubs that are been have been established. I think that is still slowly moving, and the more you hear about it, the more you know how this is going to play out. But I think hydrogen establishing some corridors for hydrogen use and production, that's going to help. And I think in the next few years we'll see a more more of this in terms of how hydrogen is going to play a role within the Canadian economy. But I think it's going to be a progressive movement in the next few years.
So, practically in the same context, how do you respond to skepticism about nuclear powered hydrogen production?
Well, first of all, I think nuclear has to be considered for in the energy mix. I think that's if we want to really move forward to really decarbonize different sectors and produce clean electricity and so on. Yeah, we rely you know in renewables that clearly has um, a big portion of the scope in decarbonizing sectors, but nuclear has to be there. That's point one. Point two is, if you have all the advantages that a nuclear plant has in terms of electricity and heat and so on, it only makes sense to think about producing hydrogen, leveraging all that is coming from the nuclear plant. Now, that is to say, of course, it has to be done properly in the right with the right assessments, the right risk assessments, and so on. Then you need to decide how you want to do it. You want to do it, in a co-location, or you want to do it away from from the nuclear fence. Those are all variations that need to be properly addressed. But I think I think the reality is very much doable. I think the risks are manageable. I think is very much needed to move forward in the big way with hydrogen production and clean energy. So I think, as I said before, it's part of engaging with the stakeholders and communicating well what the technology is and how this technology is going to be beneficial moving forward. I think countries, uh, probably a bit more related to the nuclear side, but countries that have been extremely successful in nuclear, they have engaged and they have had the people around the nuclear facilities really well engaged in terms of what nuclear does, and what the situation and paradigm and in a way conditions of nuclear are, and they can do in a tremendous work. Like Sweden, for example, they have had I think the population overall had a feel good about nuclear, and all that has been part of that effort of really being open about the technology and making sure people understand and ask the right questions.
Finally, how do you measure the success of hydrogen research projects at CNL?
Well, I think CNL has gone through, CNL as a research lab has gone through a transformation in the last few years. I think, right now, I think the success is measure of how can we leverage what we are doing to a product. So we don't want to just do a research because it's nice to do research. And all the people in our group, which more than 35 people, I think we all enjoy doing research. Is we that's what we do. But I think now we are changing our goal and say, okay, we are doing research, but the goal is to have a product out there that we can leverage. We can engage with other companies to move it forward. That's the goal. And so I think the success is going to be measured, or it will be measured in terms of, we do this, but at the end of the day, we got this product that we can just put out there for, not only moving the technology forward, but also the company is going to benefit from it.
Adrian, thank you for this interview. It was my honor, and thank you for being my guest.
It was a pleasure. Thank you so very much.
Looking to amplify your brand in the hydrogen energy sector? Welcome to H2 Energy News, your go-to platform for impactful industry insights. Every month, we connect with over 80,000 visitors and generate more than 251,000 page views. Our reach is unmatched with over 1.2 million web impressions and a loyal social media following of 9,000 plus. Our newsletter reaches 77,000 plus subscribers, decision makers, industry leaders, and innovators. Want to target specific markets? Our geo-targeting capabilities cover Europe, the United States, and the MENA region. We reach key stakeholders, 27% senior executives, 32% directors, and 20% owners and partners. H2. Energy News isn't just a news platform, it's where the hydrogen energy community converges to shape the future. Join us and let's make an impact together. Visit energynews.biz and take your brand to the next level.